it's not, it's not, it's not. All right. What does it mean if you have partial? Piece of it, okay? What does it mean for something to decompose? Break down, right? That's all we're doing, is we're going to take a fraction and we're going to just break it down, and I'll show you how this works and why it works, and you'll use it later on in math. But what you're doing is taking a big grown-up fraction and you're decomposing it, you're breaking down. If you look at this, it says each of the two fractions on the right are called partial fraction. The sum of these fractions is partial fraction decomposition. So there's going to be two parts to this. There's going to be one part where it's just write the partial fraction decomposition. And then there's going to be one where it says write it, like set it up, and then solve it. So let's look at that. All right, this is how you do it. You guys are like, what? Look, we got P over Q and all that good stuff. All we're going to do is you factor the denominator. All right, once your denominator is factored, each piece gets its own fraction, and you use capital letters to designate each different piece. So look, in this first example, do you see how there's three pieces? There's this part of your denominator, this one, and this one. You guys see that? Right? So there's three different pieces. So each piece gets its own fraction. Put it in the denominator, and then you use capital letters. That's setting up the partial fraction decomposition. Then I'll show you how to solve it. We'll do a couple today. Again, we'll finish it up tomorrow. I could do it all in one day, but it would be like 45 minutes. It's too long. So, steps to partial fraction decomposition. The first thing you're going to do is factor. Okay, we cannot forget how to factor. You're going to have to factor the denominator. Then you're going to split the fractions for each term. So every piece of the denominator gets its own fraction. And then you're going to assign each fraction capital letters. Start with A. If there's three fractions, it's A, B, C. If there's only two, it's A and B. Then we're going to talk about how to solve it, finding the values of X and so forth. So if I was just going to set this up, if it's just said set up, how many pieces in this are already here in this denominator? It's already factored for you. How many pieces are there? There's two. There's one here and one here. So how many fractions are you going to set up? Two. All right. So I'm going to put an equal sign. It does not matter which denominator you put first, which you put second. So I'm going to have here X minus 3. And then a plus. Always do a plus. You'll see the signs will work themselves out. And then I have X minus plus 5. All right. So what letter goes in my first fraction? A. What letter goes in my second? B. All right. That's the setup right there. If all the question asks you to do is set up, you're going to factor the denominator, take each piece, give it its own fraction, and then I identify the different fractions with capital letters A, B, and C. That's it. That's the setup. Very simple. Now to solve it, again, it's very simple. It's just a little bit of a pain in the butt. You're going to take your denominator and solve it. So if you were going to solve, you would say X minus 3 equals 0 and X plus 5 equals 0. So what's my X value here? 3. What's my X value here? Negative 5. So you are going to solve two very simple equations using 3 and negative 5 for X values. Oh, I'll show you in 1 second. If you guys were going to add these two fractions together over here, what would you have to have? A common denominator, right? So what would your common denominator be between X minus 3 and X plus 5? You put them together, which is right here, correct? So you're going to say, okay, what would I have to multiply this fraction by so it has the same denominator? The X plus 5. What would I have to multiply this one by so it has the same denominator? Perfect. Now have you set up an equivalent statement? The left-hand side is equal to the right-hand side, yes? So back when we were solving rationals, once you had the left-hand side the same as the right-hand side, what could you do to the bottom? Anybody remember? When we were solving rationals, if we had the left-hand side was equal to the right-hand side, what would you do to the bottom? You just cross it off, and then you just solve. So what you are now going to do is you're going to rewrite this equation. It says 6x plus 14 equals what? A times x plus 5 plus b times x minus 3. And what do you think you're going to use to evaluate this 2 times? 3 and 5. Every single time you're going to do the exact same thing. Pull your fraction apart, write your a, b, and c. Multiply each fraction by the opposite denominator so you get an equal equation on either side, and now you're going to solve. You're going to solve using x equals 3 and x equals negative 5. And again, the process of this is the exact same every single time. When I evaluate using 3, watch. I have 6 times what? 3 plus 14 equals a times 3 plus 5 plus b times 3 minus 3. What's 6 times 3?
18.
18. What's 18 plus 14? What's 18 plus 14? 32, okay. What's 3 plus 5? 8, so this is 8 what? 8a. What's 3 minus 3? 0. What's 0 times b? 0. So this is going to cancel out. Every single time, one will cancel out, and you'll be left with just the other one to solve. That'll happen every time. So right here, we're at the point where we have 32 equals 8a. What do I do to both sides? Divide by 8. What's a equal? Okay, perfect. Now we're going to do the same thing, but we're going to solve using what number? X equals negative 5, okay? So 6 times negative 5 plus 14 equals a times negative 5 plus 5 plus b times negative 5 minus 3. So what's 6 times negative 5? Negative 30. What's negative 30 plus 14? Negative 16, okay. On the right-hand side, what's negative 5 plus 5? 0, and then 0 times a is nothing. So what's negative 5 minus 3? Negative 8. So negative 8 times b is just going to give you negative 8b. You guys agree? All right, so now we do what? Divide both sides by negative 8. So b equals what? 2. So now we're going to go up to our original. And I'm going to replace a with what number? 4. So I have 4 over x minus 3 plus, what am I replacing b with? What am I replacing b with?
2.
So 2 over what? X plus 5. And there is your solved partial fraction decomposition. If you guys were going to, I'll show you why this works. If you guys were going to add these two fractions together, right? What do I need to add these two fractions together? Common denominator. What would your common denominator be? X minus 3 and x plus 5? Yes? All right, so what would you have to multiply your 4 by? X plus 5. What would you have to multiply your 2 by? X minus 3. You guys agree? Okay, so now we distribute. You have 4x plus 20 plus 2x minus 6. Yeah? What's 4 plus 2? 6x. What's 20 minus 6? 14 over x minus 3, x plus 5. which is that what we started off with? 6x plus 14 over x plus 3x minus 5. So every single time you guys are doing partial fraction decomposition, the first thing you do is factor the denominator. And then each piece, excuse me, of the denominator gets its own fraction. Then you just solve, you get an equivalent or equal to common denominator, and then you're going to solve for the missing variables. It'll all happen the same way every time. Let's do that. All right, this one's already factored for us, yes? Yeah? Okay, so write out, what does your partial fraction decomposition look like? I have one fraction that has x minus 2 in a denominator, and I have one fraction that has x minus 5 in the denominator, correct? All right, so what letters do I use? A and B, okay. Now I want the left-hand side of the equation to be the same as the right-hand side, so I have to get a common denominator, correct? If I was going to have a common denominator, I would take the two that I have and multiply them together. Everybody with me? Okay, so I'm going to say this is x minus 5. What you do to the bottom, you do where? To the top. Over here, I have x minus 2 on both sides. You guys agree? Okay. So now I can write out x minus 14 equals a times x minus 5 plus b times x minus 2. So how many times am I going to solve this equation that I just created? 2 times. What are the two numbers I'm going to use? What am I going to evaluate with? Using what and what? Where'd you get 2 and 5 from? Yep, you just set the denominator equal to 0. So, come on. I have x equals 2. Hang on one sec. And x equals 5. Yes, ma'am. Sure. So here, x equals 2. And here, x equals 5. So 2 minus 14 equals a times 2 minus 5 plus b times 2 minus 2. Okay. What's 2 minus 14? Negative 12 equals, what's 2 minus 5? This is negative 3. So negative 3a. And then what's going to happen here with 2 minus 2? 0, and then just that goes away. Every single time, guys, one of the variables will cancel. If you have 3 variables and you work it out, every single time, 2 will cancel. So you only have just one that you're going to solve for. So what does a equal here?
4.
A equals 4. Perfect. So now we're going to do the same thing over here. So it's 5 minus 14 equals a times 5 minus 5 plus b times 5 minus 2. What's 5 minus 14? Negative 9 equals 5 minus 5 is 0, and then this cancels. So what's 5 minus 2?
3.
So 3b. So we do what to both sides? Divide by 3, and b equals negative 3, okay? So how do I write this? Well, I'm going to have, what's my a? 4 over x minus 2. And then what's my b? Negative 3. So guys, you can do this one of two ways. You could write plus and then put negative 3 over x minus 5. Or if you wanted to, it could just be 4 over x minus 2 minus 3 over x minus 5. Excuse me. Can you see that? Is that all right? Does that make sense? Okay. What I would like you guys to do, if you want to, you are welcome to practice. There's some extra practice in these notes. I'm going to do them tomorrow. But if you want to just try it, get ahead. Excuse me. I have to look and see what the website is. I might just have you guys do that. Excuse me. Sorry, tomorrow or Wednesday. But